have heard that a million times. Why is that statement always said? Why do people always say, I don't understand mathematics, I don't like mathematics, mathematics is very hard? Why do you think so? At the end of the video, you'll be able to answer that question. I think I will give you a tip of the iceberg. I think many people don't understand mathematics perfectly because of the way these concepts are discussed. I'll be doing a little video on indices. The video should be a 40 minutes video tops. Then I'll of course give you in series. So I'm starting my indices series today. If you want to be a master in indices, when it comes to calculations, questions, and of course problems that relate to indices, of course you should join me in this ride. It's gonna be a four episode video, and I'll be doing my first introduction immediately after this. So join me in class, so I'll make you a guru when it comes to indices. Come back. I'll be taking indices to town, and of course you definitely will be glad you did follow me on this journey. All right, we look at the laws of indices. The laws of indices. I want to state very clearly now that the sequence is not as important as the knowledge backing the laws up. Some people like to say law 1, law 2, law 3, but it's not as important as it is to know how to apply these laws in solving equations or questions that relate to indices. Of course, when we talk about indices, we are talking about powers of a number. So let's assume we have, this is our root number. Some books disagree and say it is the base number. But I choose to say, this is my base number, this is my root number, then this is my index number. So some books will call this our base number, but in this, I want to refer to this as our root, as our base, and our index. So whenever we want to study this, we say we are studying number base. Then whenever we want to study this part of the number, we say we are studying what? Indices. So of course, we say indices is the study of the index part of every number. That is the top part of it. Some will refer to it as the power of the number. The power of the number. So we can say the root number, the power of the number, or the index number, and the what? The base number. We have law 1, or law number 1, which says that once I multiply a particular number which have different index numbers, it simply means to add them. So I can simply say this can be illustrated as maybe 2 raised to power 3 times 2 raised to power 2. In this instance, once my root numbers are the same, all I need to do is to add the powers. So in this case, I'm having 2 raised to power 3 plus 2, which is 2 raised to power 5. Of course, 2 raised to power 5 should be 32, if you know. Then we look at the second one, which is almost an opposite to this. So I can simply say, let me change this to a division. And we say whenever this is a division sign between two numbers that are the same, all it simply means is that the powers should do what? Subtract. In that case, I'm having 1. Of course, 2 raised to power 1 is what? 2. Any number raised to power 1 is that same number. So I've succeeded in explaining the usage of law 1 on law 2. Remember we said the sequence is not as important as the knowledge application. We look at number 3. Our third one says that whenever we have a multiplicative index, that is to say, we have a, or let me say 2 raised to power 3 bracket 4. So the law says just multiply the two of them up. So we say it is 2, 3 times 4, which gives us what? 2, 12. 2 raised to power 12, 2 to the power of 12. Look at the fourth law. Fourth law says any number in this world, raise it to power 0, the final answer will be what? 1. Any number you can think of. Once the number is not a 0, be it a negative or a positive number, once you raise it to power of 0, the final answer is 1. That is to say, if I have 18,000 raised to power 0 should be what? 1. 1 million raised to power 0 is what? 1. Of course, minus 3.5. Someone can say minus 3.5 raised to power 0, of course, will be what? 1. So that's the law of number 4. Look at the negative index. The negative index says that the inverse of a negative index is what? A positive index. What I mean is the inverse, that's the opposite. So if I have, let's assume 2 raised to power minus 3. So the law says whenever we have a negative index, I will say this is same as 1 over the positive of that indices. So in this case, I'm having 1 over 2 raised to power 3. 2 raised to power 3, of course, is what? 8. Of course, you should be careful not to mistake 2 raised to power 3 with 2 times 3. Most times you see a question that says maybe 2 raised to power 5. Some people will go and give the answer as 10, which is totally wrong. 2 raised to power 5 means 2 times 2 times 2 times 2 times 2 into 5 places. So in this case, we are saying 2 raised to power 3 is what? 32. Then we look at the 6th law now. The 6th law says a raised to power half or a raised to power any fraction. Once we have a fractional index, we'll invert. Look at what we want to do now. We have, let's assume 2 raised to power 1 over 2. Or let me say 4 raised to power 1 over 2, which should give us second root of 4 raised to power 1. But most times, once it is 1 as the numerator, we kind of forget it. But the truth is that the numerator should be here and the denominator should be here. So in this case, we have 4 raised to power 1, of course, is 4. Then square root of 4 will give us what? 2. So more example here should give us 8 raised to power 2 over 3. So in this case, I'm having third root of 8 raised to power 2. Third root of 8 raised to power 2. Of course, third root of 8 is what? 2. 2 raised to power 2 is what? 4. So in this case, we're having 4. Let's take some more questions. Of course, in my next class, I'll be presenting more standard exam questions. I just try to run through the laws. Remember I said, I want to repeat it again, don't bother yourself trying to know law 1, law 2, law 3, because a particular question will present itself without telling you use law 1 or law 2. All you need to do is to make sure you know the application of all these laws, so it can help you solve questions when you see them. Alright, we look at question number, we'll look at more examples. Look at more examples. Look at this. It says 16 raised to power negative 1 over 2. 16 raised to power negative 1 over 2. Of course, we said whenever we meet our negative index, we'll first of all say 1 over positive index. So we've cleared that negativity now. So we can now say 1 over second root of 16. Second root of 16 is 4. So we have 1 over 4. Remember, there's 1 here, but of course, whenever it is raised to power 1, we tend to neglect it or overlook it. Look at this. It says 125 raised to power 1 over 3. 125 raised to power 1 over 3. Of course, it's a fractional indices. So we have to first of all, as a note, let me say this. In every science, I want to say this very clearly now. In every science subject, whenever you are multiplying or dividing fractions, it's best to handle them as improper fractions. So as a standard statement, as a standard format, whenever you face questions that have to do with fractions and you're to multiply or divide, it is safer to work on them as what? Improper fractions. When you are adding or subtracting, of course, you can work on them as mixed fractions or proper fractions. But when you want to work on multiplication and division, of course, it's always best. Don't ever forget this. It's always best to use them as improper fractions. Remember, I said in all sciences, not just in math, in physics, in chemistry, in economics, it's always safer to work as what? A mixed fraction. So having said that, I can say this is 125 raised to power 4 over 3. Sorry. We have 125 raised to power 4 over 3. That's to say, I said this times this is 3 plus 1 is 4. So at this point, I can now say third root of 125. Remember, we said the denominator will become the root part, then the numerator will become the index part or the power part. Third root of 125, if you know, is 5. That is 5 times 5 times 5. Raised to power 4. Of course, 5 raised to power 4 is same as 25 raised to power 2. If you're sure, it's 625. Alright, I'll be rounding off with two more questions, and hopefully in my next class I'll be giving you more questions that relate to indices. Remember, I said I'll be presenting these indices in 4 episodes. Of course, do best to always hit the subscribe button, turn on your notification button to be sure you are notified whenever I place my next video, especially when it relates to indices. So 2 more questions before we end this video. Question number, okay, I've not been numbering, okay. Of course, you should be sure you're copying down as much as possible. Okay, we have 2 brackets, x raised to power minus 2, all raised to power 5. So we're told to simplify this. So I have this times this will give us x raised to power negative 10. That is, I multiplied this for this, having applied this law. So I multiplied this for this. Minus 2 times 5 gave me minus 10. Then of course the 2 is here. To make it more simplified, remember we noticed that there is a negative indices. We say negative indices is 1 over what? Positive indices. I'm leaving the 2 up, and I'm now bringing x to a positive 10. So this is the best way to express this question. Then the final question before I call it a day will be just like that question. It says 2x minus 3 all raised to power 2. So 2x raised to power minus 3 all raised to power 2. Notice that in this question, I never bothered to raise 2 to power 5 because it was outside the blue. I raised 2 to power 2 differently. Sorry, 2 to power 2, and of course, x to power minus 3 times 2. That is, to multiply this, we're having 4, that is 2 raised to power 2 is 4, all over x raised to power positive 6 now, because we have converted this negative to positive. So we're having 4 over x raised to power 6. I think that's where we draw the curtain for today. Thanks for your time. We always wish we have feedback from you. So in your comment section, make sure you drop a comment. Tell us how our videos have been doing. Remember to share, like, and subscribe. God bless you for tuning in today. I am still Uncle Frank Okafor. God bless you.